So, hello everyone. I'm waiting for some time, like for 3 to 4 minutes. I'm waiting so that others will also join. Then I will start this session. Just let me know that whether I am audible and my screen is visible to you all or not.
Yes, hi Himanshu. You are
Okay.
audible and visible.
So I want to let you know that in between, if anyone wants to ask some question or any doubt, then you just unmute yourself and ask because I will be not be able to see your messages here. So you just ask me and I will be answering that afterwards. So okay, I think I will start it now. Uh, hello everyone. My name is Himanshi, and I am from Department of Mathematics, IIT Jodhpur. I am a research scholar here and working in a broad area of probability and statistics. So, for today's session, I will be discussing some of the concept which has already been taught by Professor Somesh Kumar to you in week one lectures. So, I will be giving a brief recap about that. Then, after that, to make those concepts more understandable, I will be starting with some questions. So, there will be a questions problem solving session for that. So I hope everything is fine and my screen is visible and all the things are okay. Just let me know. Please just unmute yourself and tell because I will not be able to see your messages.
Yes, Himanshu.
Okay, thank you. So first of all, we will be having a brief recap, then problem solving. So uh, to let you know about the classes, so the classes will be from 6 to 8 p.m. every Tuesday. And if there are some changes, then the NPTEL team will be informing you about that. So to start with the concept which you have already been taught in your week one lectures. So the first thing I will be discussing about the limit of the sequence of sets. So if I'm considering a sequence of subsets of the universal set omega, that is an, then the limit of those of that sequence is defined through two concepts, that is a limit infimum of that sequence and limit supremum of that sequence. So limit infimum was given as the union of the intersections of the sequence an. Here we are taking the set a1 a2 a3 and we are taking the intersections. Then afterwards, and then second time what we are doing, that we are deleting the a1 sequence and we are finding the intersections from a2 a3 and so on. Then proceeding in a similar way, we are finally finding out the union of the resultant sets. So that was defined as to be the limit infimum of the sequence. And similarly, in opposite way, we have, the limit supremum of the sequence was defined. So when these two quantities are equal, then we say that limit of the sequence an is equals to the resultant quantity. So this was about the sequence limit of the sequence of the sets. Other than this, other than this, monotone sequences were defined. So monotonically increasing sequence are those sequence when the set an is contained in the an plus 1. Then we say that a sequence is increasing. And if the opposite holds, like if the successive sequence set an plus 1 is contained in the previous one, that is an, then we say that the sequence is monotonically decreasing. Now, other than this, monotone class was also defined, like a class of subsets of omega is said to be a monotone class if the for any monotone sequence the limit of those monotone sequence belongs to the class M, then we'll say that this class is monotone class. So this was about the sequence of the set. uh, Apart from this, algebraic structures were defined, like ring was defined. So it was a non-empty class of subsets of omega, where which is closed under the union and under the difference. So if any two set is in a class R, then if there for R to be a ring, the union of those two sets should be in R, and the difference of those two sets should also be in R. Then we'll say that R is a ring. So if anyone has any doubt at any point, then you just let me know. I will be addressing that. So apart from ring, this field or algebra was defined. So for any class of subsets of omega, algebra was defined to be the class uh, for which if any two elements of A are there, then their union should be there, and for any element A, its complement should be there. So it is basically closed under the complementation and closed under the union. So here we are taking union of any two sets, union of any two elements belonging to the class A. So it will be called algebra. Then apart from this, sigma ring. So sigma ring is basically an algebraic structure which is closed under the difference and countable unions. Means if I have any two set, then their difference should be in S for S to be a sigma ring. And if I have a sequence of subsets of omega an, then the countable union means I am taking the union of the set a1 a2 and so on up to infinity. Then this union should also be in S in order for that S to be a sigma ring. It These two things must follow. So in case of ring, we were taking only the union of two elements of R, but here we are taking the countable union. For the sigma ring, we are taking countable union. Now apart from this, sigma field was also defined. So basically, an class of subsets of omega is said to be a sigma field if for any element its complement is also is in F, and for any sequence for any sequence of subsets of omega, the countable union of those element is also is in F. Then we'll say that F is a sigma field. So, apart from that, semi ring was defined. So, for any class of subsets of omega, uh, that class for the class to be a semi ring, empty set should belong to that class, and for any two set, their intersection should also be in that class, and for any two set, their difference should be written as a union of elements that of that class in S. So basically, when we can write the difference as a union of the elements of that class, then we can say when these three conditions are satisfied, then we will say that the class is a semi ring. So these were the algebraic structure which was defined. Now, apart from that, coming to the statistical point of view, so what an experiment is called. So when we are observing or conducting something under certain conditions which result in some outcome, then we say that this happening or observing or conducting these things, we are saying that this is an experiment. Experiment is of two types. It can be deterministic experiment or random experiment. So basically, deterministic experiment is an experiment where the result or the outcome is known in advance. So we know that what the outcome will be. But when the outcome is not known in advance, then the experiment is known to be a random experiment, which is now random experiment are the experiment we are interested in. So in probability, we will always be considering the experiment to be a random experiment, where the outcome, maybe the possible outcome we know, but what the exact the outcome will be, we do not know in advance. So we will call that a random experiment. So whenever I'm saying that I'm talking about an experiment, that means it is a random experiment. And now, some of the basic terminologies which was given, like sample space. So what a sample space is? It is a set of all possible outcomes of a random experiment. What an event is? Any subset of a sample space, we'll call it as an event. Now, what are exhaustive events? So if I have A1, A2, AN events such that their union totally exhaust the whole set, omega, then we'll say that A1, A2, AN are exhaustive events. Now, if I have two events and their intersection is an empty set, then I say that these two events are mutually exclusive events. So these are the basic terminologies which we will be using further. Now, coming towards the probability. So, what the probability is? So, initially, the probability was defined as a ratio of the number of favorable outcomes to the total number of possible mutually exclusive, exhaustive, and equally likely outcomes. So basically, this was the assumption taken to define this classical definition of probability. So which is a ratio of the number of favorable outcomes and number of possible outcomes. So there were drawbacks of this classical definition, as this total number of possible outcomes may not be finite in general. So when n is infinity, what will be the definition of probability is not known with this definition. And apart from this, as we are considering here that the outcomes are equally likely outcomes, what if it is not equally likely, and if other circumstances are there? So this was not that good definition of probability in general. So if there are finite cases, then this definition was okay. But if there are infinite, like n is infinite, number of observation is infinite, then we cannot be using this definition of probability. So apart from this definition, other definition like statistical definition of probability was defined. So it was probability of an event was defined as so it was basically um, depending upon the observation. Like if I'm performing a random experiment and I'm observing what the outcomes are, then from there I am defining this probability. Like this probability of an event 8 is defined to be limit n tending to infinity an by n, where an is the number of times the event a occurs in n trials of the experiment. So basically this an is a number of times the event a occurs, and when n tending to infinity, this probability will be that limit. So basically, this also has its own disadvantages, like actual observations of the experiment may not always be known. So what are the possible it is not possible all the time, and also the experiment always may not be that, like there are times when the experiment is destructive, so we cannot be able to perform the experiment all the time. So this definition also has its own drawbacks. And so to overcome these things, a more general, a more axiomatic definition of probability was given. So all the things which we were defining before, like a field, a sigma algebra, and all those things. So those things was defined in order to define in order to define the probability in a more general way. So before that, I will be defining this measurable space. So if I have a random experiment and omega is a sample space, and B I'm considering to be a sigma field. So now here sigma field is considered basically. So where what we are considering, that for any A in B, A complement is also in B. So basically it is closed under the complementation. And apart from it, it was considered that for A1, A2, and all these sets in B, their countable union is also in B. So basically, what we are considering, that for any, if I'm considering any event, then complement of that event is also is in B. And if I'm considering a sequence of events, then their union, countable union, is also in B. So their finite unions will also be in B, and from these conditions also only we will be able to have a result that the differences are also in B, and the intersections are also in B. These results can be derived from these two properties which a sigma field satisfy. So basically, we are taking a sample space omega and B be a sigma field of subsets of omega. So we are saying that omega B is called a measurable space when we are taking a whole sample space with this sigma field B. Now, using this measurable space, we will be defining probability. So I'm considering here omega B be a measurable space, then a set function. Set function means we are taking this function is taking a value from a point from like point from B, means it is taking a set here like A, where A belongs to B, and it is giving it a number, like it is going towards the real line. So here it will be any element or any number x which will belong to R. So it is a function from B to R. And when this function will be called as the probability function, if probability of A is greater than equals to 0 for all A in B, probability of whole set omega is 1, and for any sequence of pairwise disjoint subsets, means their intersection ai intersection aj is equals to mt for I not equals to j, then probability of this union I going from 1 to infinity ai is equals to the sum of the individual probabilities. So basically, these three conditions are necessary in order to say that p is a probability function. So now we have considered all the definitions of the definition, basic terminologies, and the definition of the probability. So I think we are in we are in a condition that we will be discussing some of the problems. And if any one of you have some doubt in the things which I have explained here, then you may ask. So if there are no doubts, then I will be proceeding with the questions. And I expect that you people will also be answering if I'm asking some of the question from you. So are you guys with me?
Yes, ma'am.
Okay. So this is the first question we have, that we have that omega s is a sample space. So omega is a sample space basically, and as it is associated with some statistical experiment. Now what we have are to be collection of all subsets of omega, means we have all A such that A is contained in omega. So basically what it is a power set of omega. So we have all the subsets here. Now in question it is asking that whether R is a sigma algebra or not. So what R is basically A such that A is a subset of omega. Now, in order to prove R to be a sigma algebra, what condition I should have? So, any one of you can answer. So, what condition I should have? So, recently I have given you a definition of a sigma algebra. So, when a class of subsets of omega is said to be a sigma algebra?
If two sets such as subsets A and B are belongs to algebra. Oh no, sorry, that was the wrong one.
So, for any two sets, yeah.
It's getting sigma. Yeah, if for sigma algebra,
Mhm.
if the any set belongs to algebra, then the complement of the set also belongs to algebra.
Yeah. Apart from that,
A union of finite countable
countable union of the
also belongs to algebra.
yeah. So basically, if any A belongs to R, it should imply that A complement should also belongs to R. And if this A1, A2, and so on, this is any sequence which belongs to R, means basically this A1, A2 belongs to R. This implies that their countable union I going from 1 to infinity, this should also belong to R. Then we will be saying that this is a sigma algebra. So, in order to prove these two conditions, let's first consider the first one. So, let A belongs to R. So, if A belongs to R, what it means? It means that A is a subset of omega. Now, A is a subset of omega, and we also know that A union A complement is equals to omega. Now, for any event, if I'm taking union of that event with its complement, then this is nothing but the whole set. So what it is giving that A complement is also a subset of omega. So basically, this is also a trivial thing. I'm just trying to explain it more clearly. So A complement is also a subset of omega. So if A complement is a subset of omega, so it is satisfying the condition for an element to be in R. So what it implies? So it implies that A complement belongs to R. So anyone has this problem, any problem regarding this proof, like if A belongs to R, then A is a subset of omega, and A complement will also be a subset of omega. So A complement will be in R. So this is okay with everyone. Please answer.
Yes, ma'am. But
Yeah.
ma'am, can there be a case where we can say that the A complement belongs to is a subset of omega, but it doesn't belongs to R.
No, see, A complement will be R. We have defined R to be a set where which contains all the subsets of omega.
Right.
So I have already defined R like that.
Okay.
So R may be another structure. In that case, maybe there is a scenario that a complement may not belong to R. But in this scenario, what I am saying that R is a collection which contains all the subsets of omega. Now,
Okay.
since a complement is a subset of omega, now by definition of R only, a complement will be in R.
Yes. Yes. Okay.
Now for second condition, what it is now, what we will consider union, the countable union, where n is going to 1 to infinity. Now this countable union we'll consider. So let x belongs to union of n going from 1 to infinity. So I'm saying that let x belongs to this union. So what it implies that x belongs to an for all n going from, so no, for some n is equals to 1, 2, or 3. So it is basically in the union. So it may be in some of the set. Now x belongs to an, and basically what ans are? Ans are subset of omega.
Yes, ma'am.
So what it implies that x belongs to omega. So X belongs to union and X belongs to omega. So this is the condition that for any element which is in union, that element is in omega. That implies that union of n going from 1 to infinity is contained in omega.
Oh my god.
So it is a subset of omega. What it means that this union belongs to R because it is a subset of omega.
Yes.
Now, so from these two conditions, we are getting that it is a sigma algebra because both the conditions are satisfied. So it is a sigma algebra. Now, in second, it is asking that R is closed under the formation of finite unions. So as it is true with the infinite, or we can say countable union, it is true for the finite union also by the same process. So this is also true. Now in the third part, what it is saying that R is closed under formation of the countable intersections. So let's consider this option, and also we can discard the fourth option as it is saying that R is not a sigma algebra. So it will be discarded because we have already proved that R is a sigma algebra. So what we need to consider that countable intersections. So so consider the countable intersection, that is intersection of n going from 1 to infinity. So let x belongs to intersection of n going from 1 to infinity. So what it implies that x belongs to an for all n going 1 to and so on. So it belongs to every an. Now again we have the same reasoning that an is a subset of omega and x belongs to omega. So this implies that intersection of
Is closed.
n going from 1 to infinity is contained in omega. So what it implies that this countable intersection
Is closed.
is an element of R. So we have proved that it is closed under the countable intersections. So option C is also correct. So these three are correct and the fourth one is incorrect. So anyone have any doubt in this question?
No man.
So I will move forward. So I hope you people have attended all the lectures which professor has been taught.
For week one.
For week one, you have attended.
Yep.
Because if you have not attended, then this may be irrelevant for you. Or I can say that you will not be able to understand what I am like teaching or solving. So it is important that before the session, you are like totally done with your lectures and some of the problems which sir is solving in between the lecture. So then
Yes.
this problem solving session will be interesting for you.
Yep.
So so I'll move forward with the this question number 2. So in this question, what it is asking that a letter is taken out randomly from the word probability and another letter is taken out randomly from the word statistics. So basically, two words are considered here, that is probability and statistics. So here it is asking that what is the probability that they are not same. So I am taking one word from here, sorry, one letter from here and one letter from here, and and they're asking me that what is the probability that these two letters are not same.
Yes.
So like there are many letters here and in probability and in statistics which are not same. So it will be a little lengthy task to answer this question. So in place of this question, we will be answering the complement of this question, that now in order to find out the probability that the letters are
A,
not same, we will be considering the probability that the taken letters are same. So, in probability and statistics, what are the letters which are same? Like in probability, if I am saying P is not in statistics, R is
O.
not in statistics.
Basically, A and AIT are same.
Yeah, A, I, and T are same. So, so same letters are A, I, and T. Now we will see that how many times A is appearing in probability. So in probability, A is appearing one time, and in statistics, A is appearing one time. Now I, it is appearing two times in probability, and in statistics, it is appearing two times. And about T, it is appearing one time in probability and three times in statistics.
Yeah.
So what we need to find that probability of the event that the letters are same. It will be equal to probability that both the letters are A plus probability that both the letters are I plus probability that both the letters are T. So now probability that the here the letter is A is what? So how many letters are there in this word? In the word probability, we have total
I, L. 10 or 11.
11 letters we
11,
have.
11.
And in statistics total we have
10.
10 letters. So here the probability of appearance of 1 is 1 by 11,
Yes.
by that number of favorable outcomes divided by total number of outcomes. And here in statistics, the appearance of A is, the probability of appearance of A is 1 by 10. I hope that there is no issue in writing this 1 by 11 into 1 by 10.
Yeah, that's intersection.
Yeah. Now, plus probability of appearance of I in the word probability is
2 by 11.
by 11, and in the word statistics is 2 by 10.
Yes.
Now, probability that it is T is appearing in the word probability is 1 by 11, and for the word statistics, it will be 3 by 11.
Yep.
So,
1 minus 8. 1 minus 8.
so it will be 1 plus 4 plus what that was
3
3
by 110.
by 110. So it will be
8 by
8 by 110. So this is 4 by 55. Now, since we have find this, that this is the probability that the letters are not same. So, in order to find out that probability that the letters are, we have find that letters are same. So, we need to find that letters are not same. So, it is the complement of the probability that the letters are same. So, it will be 1 minus 4 by 55.
50.
So, it was 51. It will be 51 by 55. So any doubt in this?
No. No, ma'am.
Okay. So I will be proceeding towards the other question. So here the question is, so I just request to other people also to just say something so that I am able to see that how many students are with me. Otherwise, it will be a boring session for you all. Okay, so I will be moving forward toward question three. So the question three is saying that two digits are selected randomly without replacement from 1 through 9. So we have
932.
yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now from that we are selecting two digits without replacement. So basically, when I selected one, then I had eight choices. First of all, for selecting for first digit, I have how many choices? Nine choices I have.
Yes.
I can choose any one. Now for the second selection, I have only eight choices because I have already selected one number. So total number of
Option
outcomes your choices I can say is
9 into
9
8.
into 8, that is
Okay.
72. Now what it is saying that find the probability that the sum of the numbers is odd and the first number is 2. So it is saying that first number is 2, so it is fixed basically that first
120.
number is 2, so it is fixed. Now what we are saying that the sum of the both the numbers is odd. So what choices we are left with for the second digit is if I will add one to it. So
1,
for this I
3,
have one
3,
and three,
5, 7,
five,
and 9.
7, 9. So these are basically number of favorable outcomes. So total outcome is 72 and favorable are how many? One, 2, 3, 4, 5. So basically,
5 by 8.
yeah. So favorable number of favorable outcome is equals to 5. So probability that the first digit is 2 and the sum is odd, I guess, is
Yes.
equals to 5 by 72. So
Yes.
this is basically the answer of this question.
Again. Interception. 5 by 72.
5 by 72, yeah. Okay, so I had already done one question with this sigma algebra. So and also I have discussed the definition of the sigma algebra. So just I just request all of you to solve this question, which is saying that we the whole samples is consist of these three elements 0, 1, and 2. Now we need to find that which of the following is not a sigma algebra. So you just solve it and let me know that what are your answers. I request all other people also to participate, and it will be interesting for you all. You will be understanding the concepts and the things better.
Option
So
B.
option. So you are saying option B is correct.
Yeah, because you have written singleton 0. The complement of singleton 0 is 1 comma 2. It is not present in the set.
Yeah. So for option B, I'm getting an answer that since we have this set, and if I consider this element of the set, so the complement of this will be 1 comma 2, and which is not in this set. So this is not a sigma algebra. So since I'm asking here that which of the following is not a sigma algebra, so option B is correct, that this is not a sigma algebra. So I hope you have checked all other options also.
Yes, ma'am.
So all others are sigma algebras. So this, all the A, C, and D option, these are sigma algebras. And
Ma'am, can you explain the C option once?
okay, so what the C option is saying, what we have. So the set is
Phi and
phi and S.
yes,
So what is phi? So if I take phi complement, then it will be S.
yes.
Okay, so it belongs to the set. So let me name it E. Okay,
Okay.
so it belongs to E. Now, if I take S complement, so it is basically phi. So it also belongs to E. So it is closed under the this complementation. But if I'm taking union, then phi union S is S only. So it belongs to E. And phi intersection S is phi. So
But
it
also
will belongs to E. So basically, sorry, not intersection. Phi union and S is only we need to consider.
yeah.
So the condition of union is also satisfied, and the condition of complementations are also satisfied.
Yes. Okay. Yeah.
So it will be a sigma algebra.
Sure.
So other option also I will discuss so that the others who may not have solved this, so they will be getting an idea. So for option A, what it is, phi 0, phi, I have 0 in this, 1, 2, and S. So S is basically 0, 1, 2. So now for this phi complement is S, as everybody knows, so it will be in this set F, and 0 complement will be 1 comma 2, which is again in F. S complement is phi, so it will be in F, and 1 comma 2 complement is 0, which is in F. So it is closed basically under the complementations. Sorry. And we will take this for the union. So a union of phi with every set will be that set only. So that is again in F. So there is no need to do this with phi. Now if I take 0 union 1 by 1 comma 2, so it will be S only. So it is again in F. And 1 comma 2 union S is S again. So it will be in F. And 0 union S is again S. So with S, everything is S only. So it is again in F. So I hope everything we have covered. With phi, we have all these sets to be equal to that set only, which is in F. And with 0, with 1, 2. So it is basically closed under union and closed under complementation. So it will be a sigma algebra. So this option is incorrect. And as I have explained for option C, this is also incorrect. Now for the last option, for option number D, uh, what are the elements?
Ma'am, but
5.
if we take a union of phi and one, then that is not there in the.
No, see. You are taking union of phi. Okay, let me. So you are taking union of phi and 1.
Yes.
So you will take the unions of the elements which are in the set. No, 1 is not in this.
Okay.
So
Sure.
F is basically a class where there are subsets of S. But one, the subset which is singleton one, it is not in F. So we will not consider that.
Okay. Sure.
Okay. So this will be not this is not in the set. So what is the option D? 501 option D 50. So here the one is there. So we will consider that 501. Okay, let me 2. I have 01 and 02, 1, 2, and whole S. So here I will say that its complement, 0 complement will be 1, 2. So it is again in this set. I may name it as G. So it is again in G. And 1 complement, which is what? 0, comma 2, which is again in G. And 2 complement, which is 0 comma 1, so it is again in G. And 0 comma 1 complement, which is singleton 2, which is again in G. 0 comma 2 complement, which is singleton 1, which is again in G. And last one, 1 comma 2 complement, which is 0, which is again in G. And since S is a whole set, so S complement, which is 5, which is again in G. Now, apart from that, if I take unions, so you can see that 0 union 1, so it will be 0 1, 0 union 2 will be 0 2. So 1 union 2 is 1 2. And if I take all the three, so it will be whole S. If I take 0 1 and 0 2, it will be whole S. 0 2 and 1 2, it will be whole S. So like that, the all the unions will also be there. So all the unions will also be there in G. So G is a sigma algebra. So if anyone has doubt in this, you may ask.
No, ma'am.
Okay. So this is also a sigma algebra. So it is this option is also incorrect. So option B is correct one. So anyone else have any doubt, or I may proceed further? Okay. So this is question 5. If a single draw is made from a well shuffled pack of cards, so it is a well shuffled pack of cards. So first of all, total number of cards will be 52, as we all know. So a single card is taken out from this well shuffled pack of cards. What is the probability that the drawn card is queen or a heart? So first of all, let us see that how many queens are there. So number of queens will be 4,
Yes.
and number of hearts will be 13. So so what is the probability that the drawn card is queen or a heart? So it may be a, so let us consider an event. Let A be an event. Let A be an event is a queen. So if I draw a card which is a queen, so that will be the event A. Now, okay, so So, and let B be an event that the drawn card is a heart. So, since we know these two events, that the drawn card is a queen and the drawn card is a heart. Now, what will be the probability that the drawn card is a queen? So, what will be the probability? So, how many favorable outcome we have for queen? We have four number of favorable outcomes, and total outcome is 52. So, probability that the drawn card is queen will be 4 by 52. Any doubt in this?
No, ma'am.
So it will be 4 by 52. And what will be the probability of B? So B is the drawn card is heart. So it will be 13 by 52
13 by
since the
50.
the number of hearts are there 13, and there are 13 hearts, and we have total number of outcomes to be 52. So what we have now, probability of A and probability of B we have, but what is it asking? What is the probability that the drawn card is a queen or a heart? So what you conclude from this? Whether is it asking for the union or for the intersection?
Union.
Union. So it is basically saying that the card can be a queen or can be a heart. So if it was and, then we will be focusing on the intersection. Now it is asking that what will be the, so the question is the probability of A union B. Okay. So just first let me know that what the A intersection, what will be the event A intersection be? Just formulate in words. That what will be the event A intersection be?
Queen of Hearts.
Yeah. So uh, queen, the drawn card is queen of heart. So probability of A intersection B will be what? So there, how many queen of heart is there? Only
One.
one. So it will be 1 by 52.
52.
So, as we all know, or the professor has already been told that probability of A union B is equals to probability of A plus probability of B
B minus
minus the probability of their intersection.
B. Yes.
So what will be the quantity? 4 plus 13 minus 1 divided by 52. So it will be 16 by 52. So you can simplify it further. So it will be 16 by 52.
It will be 4 by 13.
Yeah, 4 by 13. 4 by 13. So any doubt in this? So majorly what you need to understand here, this is basically the formula, but you need to understand that what is it asking about the probability of which event has been asked in the question, then you need to answer that only. So this is the main thing in this question or this type of questions. So I hope this is clear to all of you.
Yes.
Okay. So we will be moving forward with this question number 6. So here, if I can see the options, they are saying about that whether the collection of the subsets is a ring or a monotone class or a sigma algebra. So basically, we must know that what a ring is, what a monotone class is, and what a sigma algebra is. So as we already discussed, that sigma algebra is, it satisfies two conditions: the complementation and the unions, countable unions. What about a ring? So uh, for a ring, two conditions must satisfy. What are those conditions?
A union B belongs to ring and A minus B belongs to ring.
So for a ring, two conditions were that A minus B should be in R, and A union B should be in R if A and B are in R.
Yes.
So difference should be in R and union. So first we will focus on the ring. So let us consider this first set, collection of set, or I can say. So let me name it as set E, which consists of the elements like En which is equals to closed 1, so closed 0 and open 1 by n, where n is running from 1 to. So all of you, you may just see or note down this set en, sorry, this set in option A. So what this set is, first of all, let us analyze this set. So basically, if I have a line, here I have 0, here I have 1. So if I consider this E1, so what it will be? It will be 0, comma 1, open. So basically in this set E1, we have 0, but we do not have 1, but we have the all the intermediate numbers we have in this E1. Now in E2, so this is basically E1. Now E2 will be what? 0, comma 1 by 2,
Comma.
open. So what we have? We have 0 again, but we have up to 1 by 2 only. So this is our E2. So you may notice that this E1 contains E2. And we if and will move further, this again will contain E3 and all those elements. So this is a simple observation that all the further elements of E are like E1 is containing E2, E2 is containing E3, and E3 is containing E4, and further the chain is going like that. So since E1 and E2 are like that, so if I consider first of all their union, so since E1 is containing E2, so their union, E1 union E2 will be E1, or
Yeah.
I can say E1 union E3 will be E1 because E1 is a superset. E1 is containing all other sets. So union, it is closed basically under the union, but what about the differences? So it is
Difference
closed,
also belongs to R.
it is closed under union. So union is done. Now, what about difference?
Difference of E1, E2 will be from 1 by 2 to 1, which also belongs to E.
So okay. So what will be the difference? E1 minus E2.
Correct. Or maybe
So
wrong.
E1 is 0, comma 1, and we are
Yes.
subtracting 0, comma 1 by 2. Okay. So just let me know what this difference will be.
1 by 2 to 1.
So
Close bracket.
1 by 2 to 1. So 1 by 2 is closed or
Yes.
open.
Closed.
Closed 1 by 2 to 1.
1.
Now, whether this belongs to E?
Yes. No, no, not
No.
specifically.
You.
Yeah.
So it does not belongs to
Yeah.
E.
Yeah. It's
So it is not closed under the difference.
difference.
So basically it is not a, okay,
Right.
let me add a slide.
Okay. Okay. Now,
So here E1 minus E2 does not belongs to what the set was E. So what it implies that it is not a ring. So first option is incorrect.
yes.
So anyone has any doubt in this?
No.
Okay, so just see the set which is given in option A and set which is given in option C. They are same. So the collection in option A and collection in option C are same. So let's analyze it further. So it is asking that whether it is a sigma algebra or not. So we need to further analyze it in the direction of sigma algebra. So for sigma algebra, what if A is there, then A, if A is in E, then A complement should be in E, and the countable union should be in E. This is for the sigma algebra. So let's start with the complementation only. So let's consider the element even. So even was the element. What was even?
0 to 1.
0 to 1, closed 0 and open 1. So let's consider its complement. So what the complement will be?
5.
5. See, our the
Oh,
whole sample space is R.
okay. So it
So
will 1 to infinity.
so okay, we have omega is what? Omega we have R.
Us.
And R can be written as minus infinity to infinity. Okay. So we are considering basically its complement. So we are deleting these elements from this set.
Minus infinity to 0, then
Yeah.
1 to infinity,
Yeah.
union
So
of
it
both.
will be minus infinity to 0 and 0 will be open
Yes.
and union it will be closed 1 to infinity. So whether this set belongs to E or not, so it does not belong to E.
No.
So what it implies that E is not a sigma algebra.
Hmm.
So this option was that only that En the collection of set En is not a sigma algebra. So this is a correct option. Okay, so now we will be considering collection of the sets like uh, option B. So what are the elements? Elements like open 0 and closed 1 by n. So let me consider this as Bf, and here the elements are like Fn, which is equals to
Open 0, close 1 by 1.
open 0 and closed 1 by n. Open 0 and closed 1 by n, where n going from 1 to. So in what direction we need to analyze it? Whether it is a monotone class or not. So first of all, what a monotone class is?
Limit of the of the elements belong to class.
Yeah, so basically what it is, a more um, precise definition is for any monotone sequence. We are saying, okay, for any monotone sequence, Fn I will consider for any, like it can be a monotonically increasing sequence or can be a monotonically decreasing sequence. Its limit should be in M for M to be a monotone class. So, okay, so further, what we will, first of all, we will see that how the elements are. Like, if I consider F1, so F1 will be what? 0, comma 1 closed. And F2, it is 0, comma 1 by 2 closed. F3 is 0, comma 1 by 3 closed. So you can see that F1 contains F2.
It's a decreasing.
Yeah, so it is basically monotonically decreasing sequence. So it is monotonically decreasing sequence. So as already been proved by sir that for any monotonically decreasing sequence, what result we have, where it limits goes. Okay, let me just. So if I have a monotonically decreasing sequence, like this. So let me just write the statement. Sequence of sets actually, which are basically subsets of omega. So this is not very precise statement. I'm just stating it. You must have written it by yourself when the sir has been discussed it. So for any monotonically decreasing sequence of sets which are subsets of omega, the the limit of the sequence is basically, so it is like en if I'm considering. So limit of the sequence is equals to the intersection. It goes to the intersection of the ens. So basically the limit en is equals to the intersection of all the elements in the sequence. So here how the elements are like 0. So here what the elements are like, E1 is 0 comma 1 by 2, sorry 0 comma 1, then 0 comma 1 by 2, 0 comma 1 by 3, and here we just notice one thing, that 0 is not there in any set, not in the first one, not in the second one, not in the first one. So 0 is not there in any of the set. However, the element in the right hand side are there in the set. So uh, if I consider En to be 0 comma 1 by n, and we know that when n tends to infinity, this 1 by n will go towards 0. So so the sequence of the ens will go towards their intersection. So 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 what will be the limit en will be the intersection of the ens. So which is basically what? So how our en is, and going from 1 to infinity, our en is like 0 comma 1 by n. So if I take the intersections, at last where I will land? I will land towards 0 when n goes to 0. If I'm taking the intersections, like if I'm taking intersection of 0 comma 1, intersection 0 comma 1 by 2, if I'm taking, sorry, 1 by 2, so it will be what? So it will be 0 comma 1 by 2, where 1 by 2 is open.
1 by 2 is closed.
So it will be open because 1 by 2 should be in both the sets. So okay, so 1 is closed here, so it will be closed. Okay, thank you. So it will be closed. So 0 comma 1 by 2. Now again, if I'm taking intersection of this set with the next one, this is 1 by 3. So what it will be? It will be 0 comma 1 by 3. So it is basically going towards 0.
Comma
So
0.
when at last when I take the intersections of en going from 1 to infinity, so it will be 5 because 0 is not in the set and the limit is going towards 0 only. So it will go towards 5. So the limit will be, so the limit will be 5. So the for a monotone class, limit should be in the set. Okay, so limit should be in the set, but in this set Fn, phi is not there.
Yes.
So basically, it is not a monotone class.
Yes.
So this option is also incorrect. So from that we can say this option D is correct for us. Said that this collection of subset, Fn is not a monotone class.
Yes.
I hope it is clear, na?
Yes.
So option C and D are correct. So now we have question number 7. So any other person, anyone who have any doubt, please ask. I will be happy to answer.
Three.
Okay, so I will be moving forward. So this is question number 7. So here what question is saying that cards are drawn one by one without replacement from a well shuffled pack until an ace appears. So basically, first of all, we will write that what total number of cards we have, total number of outcomes I can say is equals to 52 for an event that we are drawing a card without a replacement from a well shuffled pack of. Now how so what it is asking that find the probability that exactly 3 cards are drawn before the ace appears. So basically how many cards we are drawing 4 cards. So and it is asking that what is the probability that exactly 3 cards are drawn before the ace appears. So first time when the ace is appearing, it is appearing fourth time we are drawing a card. So here this is ace. So what is the probability that first time this ace will appear at the fourth place? So here, so how many, first of all, how many possibilities for this card is? Total
4.
number of possibility for this card is total
4.
number of possibility.
52.
So we cannot have 52 possibilities at the first place because we need
48.
that.
48.
So how many?
48.
Yeah, 48 because we are subtracting those 4 aces from here. So which is basically 52 minus 4. We are subtracting those 4 aces from here. So we are getting total number of possible outcomes for this is 48. Not total number actually, it is
Number of
favorable actually. Yeah, so it will be favorable outcome. So total will be as you said 52 only. Favorable will be 48 because we want ace at the fourth place.
Yep.
Okay, so for this it will be 48. Now for the second place, favorable will be
47.
47 and total will be
51.
51. We have subtracted 1.
Yeah.
Now for this place, favorable
46.
we have 46 and total we have
50.
15. And for this favorable we have
4 by
4 and total we have
49.
40
9.
40
9.
49 because 3 are gone in the first 3 choices and we have 49. So we will calculate it. So probability will be what? 40 hours, yeah, 48 by 52,
47 by 51 into 46.
47 by 51, 46 by 50, and 4 by 49. So you just calculate it. Calculate and let me know the answer. So you just convert it into decimals, I guess, and just let me know what the answer is coming.
Approximately 0.064.
Yeah, 0.0.
64.
Okay, so this is the answer of this question. So anyone of you have doubt in this? Okay, we will move forward for this question. That out of a group of students, so we have a group of students. So basically, omega is our sample space where we have students. How many students are there? We do not know. That S1, S2, dash dash dash, Sn maybe the elements in omega. What the n is, we do not know. So out of a group of students, so 21 study biology. So how many students study biology? So let the name of this event to be B. So it is an event that the students study biology. So how many students? So number of elements in this event B is 21. So you should have this idea that when I'm saying that this is number of elements in the event or the probability of the event. So basically here they are saying that 21 study biology, and I'm saying that B is an event that how many B is an event that the students which study biology. So like we are saying that B is an event that in which how many students comes. It comes there. So it comes student S I. We do not know which students are there, and the cardinality of B is 21. So there are basically 21 students in this uh, set. So number of elements in B is 21, and other than this, 37 study English. So let E be an event that student study biology. So the number of elements in E are how many students study biology? 37. Now, apart from this, 49 students study physics. So, let P be an event. The student study physics. So, number of elements in P is how many? 49. So, if I make a Venn diagram, so there are three events that. Okay, let me read first. So there are three events from which out of total group of students, 21 study biology. So there is one event that students study biology. Other event is students study English, and the third event is that students study physics. So let me name this event as E, P, and B. So we have number of elements of these events to be with us. Now, apart from this, 9 of these students study physics. So number of elements in which event? 9 of students study physics and English. Physics and English means which event we are considering here?
Intersection.
Intersection. Which intersection of which event?
P and E.
P and E. So we are considering basically number of elements in P intersection E. So which is 9. Now other than this, 5 study English and biology. So number of elements in E intersection B is 5. So basically, all the elements or all the numbers are greater than 1. So we can conclude that by directly that these are not probabilities. Basically, we are talking about the number of the elements in the event, not about the probability of the event. So just make that clear. So five study English and biology, four study physics and biology. So physics and number of elements in physics intersection biology is 4. And other than this, three students study physics, English, and biology. So there are three students which study English, physics, and biology. So we have all these numbers with us. Now, what is it asking that how many students study at least one of three subjects? Now, what does it mean? At least one of these three subjects means which event we are considering?
Union.
The union. So we are basically considering union of all these events. So physics, union biology, union English. We have been asked about number of students in this. So since we do not have any formula for this number of students, but we have the formula for the probability, that probability of P union B union E is equals to probability of P plus probability of B plus probability of E minus probability of their intersection, their like intersection of two events, minus probability of P intersection E plus the intersection of all the three. And we also know that probability of this event is what? Number of elements in this event divided by the total number. Let that cardinality of the total sample space, we have already taken that the total number of students are n here, or I can take it as capital N. So I have taken the cardinality of the sample space to be capital N, that there are total number of n capital N students. So for that I have taken this probability of P union B union E will be the number of elements in the event divided by the total number of elements. Now probability of P will be number of elements in the event P divided by total number of elements in B divided by total plus number of elements of E divided by the total minus number of elements in P intersection B divided by the total minus number of elements in the intersection B divided by the total minus number of elements in P intersection E divided by N plus number of elements in whole intersection of the three events divided by N. Now we can see that we can cancel this capital N from both the sides, and what we are here now with so here we are with number of elements in A union B union C is equals to number of elements in A plus number of elements in B plus number of elements in here we have given another name to our events, so I will be following that only. Okay, so what was that? P union B union E, so it will be NP plus NB plus NE minus NP intersection B minus NB intersection E minus P intersection E plus NP intersection B intersection E, and we have all these quantities with us. So what are they? 21, 37 and 49. So it is 21 plus 37 plus 49 minus So ordering may be different. Like I have written number of elements in P. It may be different because it is a little difficult for me to go back to the slides and see what exactly it is. So I hope you understand that. So P intersection E contains 9 elements. So minus 9 minus number of elements in B intersection E is,
5.
so it is 5. And in P intersection B it is
4.
4, I think. And in the whole intersection there are three elements. So just what the sum is?
40, 60, 71.
72.
72.
107 minus 9 minus 5, 14, 18. It's 92, I think.
Yeah, it's 92. So please just check on. Maybe you have taken some values wrong. That's why you are coming up to 72. So it is 92 basically. So if the probability was being asked, like probability of P union B union E, so it will be of course 92 divided by the total capital N. However, we do not know what the total number of student is. So if the total number of students were have been given, then this will be 92 by N, capital N. Okay, so I hope there is no doubt. So this was
No, ma'am.
basically the use of uh, the formula that probability of A union B is equals to the probability of A plus B, and the difference from the intersection. So the main thing is whether what you are understanding from the question. Like you just see that where we have to put the intersection and where you have to put the union. Then you are basically done because you know the concept. You just try to understand the question, then you're done. So so we will be moving forward for the next question. So I hope that you are understanding the things whichever things I'm discussing here, and there are no, like if there are some problems with you or there are some doubts, then you can like discuss it with me. I'm like happy to answer, because we are left with 2 questions now. We will be discussing those 2 questions, and then you can answer whatever the doubts you have. This question 9, you just read it and try to solve it yourself. So what the question is that in a box there are 5 blue. So let me explain it first. So we have this box. So there are 5 blue balls and X green balls we have in this box, and we have X plus 2 red sorry, balloons we have actually. Balloons we have, and we have 6 black balloons. So this is a box, and we have these blue, green, red, black balloons in it, and the number of balloons are given 5x, x plus 2, and 6. So a balloon is selected at random from the box. So one balloon is selected. If probability that it is a green balloon is 1 by 3. So what is given, that probability that balloon is green. So it is 1 by 3. Okay. So we have this probability. Find the total number of balloons. So what is the total number of balloons? We need to find it. So just try it yourself. It is a easy question. There is no very big concept or very big thing is like we are using it here. This is an easy question. You can be easily be able to solve it. So just solve it. Just let me know that what is the total number of balloons. So I hope the question is clear with all of you now.
Ma'am, answer is 39, ma'am.
Okay, so what the answer is?
39.
So you are saying that total number of balloons is 39.
Yes, ma'am.
What's your name?
Yogeshwari.
So let me write it in a short form. So it is a answer by Yogeshwari that the answer, the total number of balloons is 39. So all of you, all others, I think there are 7 or 8 people here. You people also solve it and just give me the answer that what the answer is coming. How many total number of balloons are there according to you?
The answer is 39.
Okay, so another. 39. So there are 2 votes for 39. So other people also, you just try to calculate it. It is a like easy question. It is not very like big or something very new. Basically, you just have to use the formula of total number of outcomes divided, the favorable outcomes divided by the total number and equate it to 1 by 3 to the probability of the green balloons. So anyone else who is solving yet? So no one is solving. So okay, I'll explain it to other people.
13,
I hope, yeah,
13, 1, 3.
1 3. So okay. So what's your name?
Meenal.
Okay, I may. So Minal has answered it 13. So you're sure that you have counted the total number of
No,
balloons,
total number of
not
balloons is
the
39. I have counted the green balloons. I'm sorry.
yeah. So you have counted x. So you have counted x to be 13. Then total number is 2x or whatever the equation 2x plus 13. So that will be 39. So okay, I hope all of you have tried. So let me explain it. Then we will move forward. So basically, what the question is saying that probability of green balloon. The probability of green balloon is 13, 1 by 3. So number of elements, or I can say number of green balloon is equals to x, which is given in the question. So probability that we get a green balloon will be nothing that the number of favorable outcome, that is x, divided by the total number of outcomes. So total number of balloons are what? So we will calculate it in the form of the algebraic equation. So since there were how many 5 blue balloons plus we have x green balloons plus x plus 2 red balloons. Okay, red balloons plus I think we have 6 black balloons. So these were total balloons. So which is equals to nothing but I think 2x plus 6 and 5 11 and 6 plus 5 11 and 2, that is 13. So these are total number of balloons. So probability that we have green balloon is 1 by 3 and it is equals to number of green balloons, that is x, divided by total number of balloons, that is 2x plus 13. So we'll just cross multiply it and we'll find that 2x plus 13 is equals to 3x. So 13 is equals to 3x minus 2x, so it will be x. So the value of x is 13. So basically we are getting that number of green balloons is 13. So total number of balloons will be 2 into 13 plus 13. So it is 39. So I think 3 persons have solved and all the 3 have answered it correctly. So I hope it is clear with all of you that the total number of balloons is 39. So we will be moving forward to the next question. So the question is, in a game, a 6-sided affair die is rolled. So basically a 6-sided affair die is rolled. So our sample space is what? 1, 2, 3, 4, 5, 6, because the die, we are rolling a die. Now, if event P is defined as getting an even number. So what an event P is? P is getting even number. So what will be the elements of that event? So what are the elements in this set? So what are the
4 and 6.
what 2, 4, and 6?
Yeah.
So these are the elements in this event. So event Q is defined as number greater than 2. So Q is an event which is defined number greater than 2. Okay, greater than, it is greater than 2, not equals to. So it will be 3, 4, 5, 6. So we have P and Q with us. Now what the question is asking, that P and Q are mutually exclusive. Okay, so first of all, we have a question of mutually exclusive, that whether they are mutually exclusive or not. Reasoning, we will consider it later. So for an event to be mutually exclusive, for two events to be mutually exclusive, so we have two events A and B, then if A intersection B is empty, then they are mutually exclusive. Okay, so here we have P and Q. So P we have 1, 2, 3, 4, 5, 6, and Q we have 3, 4, 5, 6. So basically P intersection Q is what?
4, 6.
4 and 6. So basically even number. So what that event is? Even number which is greater than 2. So this is basically the name of this event. So these are not mutually exclusive because their intersection is not empty. So what it implies that P and Q are not mutually exclusive. Okay, so our first option is gone. Second option is also gone. So it is they are not mutually exclusive. So basically we are left with option C and D. So what reasoning they are giving, that P and Q are not mutually exclusive because getting an even number does not exclude the possibility of getting a number greater than 2. So according to you, is it correct?
Getting an even number.
Yeah, so it is correct because getting an even number, it does not exclude the possibility of getting a number greater than 2. So
Yes.
basically, it is a correct option. So P and Q are not mutually exclusive because the same thing, even number, having an even number does not exclude the possibility that the number is greater than 2. Now, what other option is saying P and Q are not mutually exclusive because there are numbers that satisfy both conditions. So
Yes.
basically, it is true that getting an even number and getting a number greater than 2. So some of the numbers are there which are satisfying both of the conditions, which are like in event A, in event P, and event Q. So D option is also correct. So I hope this is clear. This was just a basic question which was based upon a basic concept of mutual exclusive event.
Yes, ma'am.
Okay, so these were the 10 questions which I have prepared for you to like. I hope this will help you to understand the concept better. So, if there is some doubt in any of the questions there or any of the concept which I have discussed today in this session, so you may ask that question or any other question you have, so you can ask.
Ma'am, can you refer a book of an Indian author for the like this?
For this course.
Yes.
So for that, I just let me know what your background is, like what you are doing and how you see this course.
So actually, I'm a part of a corporate finance field, and I'm doing it for a for my planning for my as a part of future plans, basically.
Okay. So you have a prior knowledge about this probability statistics subjects, or first time you are reading it?
So I've studied maths till class 12,
Okay.
not thereafter.
Okay. So if you go to like a more applicative side of this like subject probability and stats, so very basic book is there of like S SM Ross is there. There are two books actually. There is Introduction to Probability Models, and other one is Probability and Statistics for Engineers, and some other, like I do not know remember the whole title of the book, so but you will get it online. So these are the two books. In the first book it was basically like it covers all the concepts of the probability, but in the second books we have probability also and we have statistics also. So these are the basic books, like these are like easy to understand books. So you may follow that first, and there are many other books also, but you can follow this also, like we have other book also, like VK Rohtagi is the writer. That is Introduction to Probability we have, and for the same writer we have Statistical Inference. So these are the basically title of the books. So these two writers are there, and also there is a professor of IT Delhi, Professor Dharmraja, and his book is also there. I do not like remember the title of the book, but you can search it. You will be able to find it. So that is written by this Professor Dharmraja, and I think these will be enough. This SM Ross, if you will like read and the concept, you may be able to like easily understand this book. And apart from that you can also follow this Rohtagi, but since like I have also like discussed this algebraic structure and those theoretical concepts which involves in probability or the axiomatic approach to probability, those concepts are very well given in this book of Rohtagi. However, this SM Ross is like more on the application side, like how are the questions are solved, how it is approached in an applicative way, but a theoretical concept you can better understand from Rothwell. So it is basically a like theoretical.
And can you share an email for like future references in case there are any queries and everything?
Okay, my email. So
Yeah.
you can also put your queries in this there is some in your NPTEL the where you log in your like you have this interface, no? So there you just log in, and there is also an option to post your queries and the doubts you have. So you can do it there also. However, I can share my mail. My mail, I think it is. Wait, let me share it. So it is P22MA002 @ but it is better to post your queries there in the NPTEL or the NPTEL website where you must have access there, but you can also share it at my mail, but maybe there may be some delay in answering those questions. So, and also you can like regularly attend these sessions. I will be every week I will be having this session with you, then you can just clear your query from there also.
Sure. Thank you.
Okay. So other than this, anyone have any doubt? So you guys are liking the lectures which you are attending by Professor Sumesh Kumar?
Actually, the video quality is very
Yeah,
bad.
yeah, actually, yeah, it is a little poor. So I think you have to adjust on that. Uh, Actually, there may be some reasons for that. So the video quality, apart from video quality, I think the other things like the concepts and the things which has been explained already, which you can already maybe I think you must have some of the interactive session with the professor also. I don't know like you will be having or not, but I think there are some sessions which you will be having with the professor. So from there also you can like ask your doubts or the things you can discuss with the professor.
No, I think
So
till now there were no sessions. Maybe in future.
maybe in future, okay, yeah, because there is only like 2 week lectures are given.
Yep.
So after some time you may be having some session with him also.
Yes.
So you people have registered the course or you've just enrolled it?
Right now enrolled.
Okay. Okay. So if you guys want something else from this like kind of sessions, you can suggest anything which you want that I can do better, or any feedback if you want to give, you can give. I will be uh, uh, including those things for my future session. So you can just for anything like for the writing, for the speed of my like speaking, anything you can you want to suggest or something like that, you can also suggest for that, because these lectures are for you only, and it is very important that you people understand the things which I'm explaining at least.
Yeah. Today's class was good. Yeah. Thank you. Thank you for the class.
Okay. Okay, anyone else, anyone have any doubt, anything?
If you give a definition, if you give the examples also, it will be better understanding for us.
Yeah,
When
yeah,
you give
it's okay.
ring,
Yeah.
field,
Yeah, I understand that. Actually, this session was just for the problem solving. That's why I have not included the examples, because sir has given already. But okay, next time, if the time permits, I will be including some of the examples, so you will be able to have a broader understanding of the concepts. Because here, actually, the thing is like you have to go through the lectures, and you have to like attend these sessions for the problem solving. So, okay, I will be including some of the examples for the definitions and all these things, so you will be understand it better. Anything
thank you,
else?
ma'am. Thank you, ma'am. Thank you.
Okay, thank you. So I hope you people are okay with this PowerPoint presentations and all these things.
Yes,
And
ma'am.
the like slides and all these things are okay with you? Because this is my first lecture, I need to understand what you people want from these classes. Actually, it is it is for the problem solving, but uh, apart from problem solving also we can like discuss things, we can also discuss the concepts, we can also discuss the examples and all these things. And I hope before attending the lectures, you people just go through the lectures of the whole week, and also you just go through the assignments which you have already been assigned. So it will be easy for you to at least understand that what type of question you will be having further with the course. And it will be helpful for me also that you people are with me and like solving the question, because if the class is interactive, that there will be like interest, that will be interesting for me also. If you people will not answer, then the class will become boring, and I will also think that no one is answering it. Then what is the point of like discussing all these things? So you people just join the class and ask your doubts, and just like discuss the questions, have a better understanding of the concepts. So
Yes, ma'am.
I hope next time you all will read the things, and the persons who are not speaking today, I want them to be speaking like and discussing the things with me, and solving the questions obviously.
Yes, ma'am.
Yeah. So I will be ending this meeting if there are no doubts and there are no further queries for that. So, okay, let's meet for the next session on Tuesday of next week.
Sure.
Okay, I will be ending this meeting now. So, thank you for participation. Okay, I will be ending.